Good morning, everybody. Welcome to our webinar. We're thrilled to be hosting today a webinar which is part of our Open Science webinar series. And it's our last webinar of 2021. As we wait for a few more people to join, just give a quick introduction to our guest today. Emma Ganley is joining us from Protocolsio. Emma is an experienced journal editor before joining Protocolsio in 2020, she was chief editor of PLOS Biology. She is an expert in open data, open science, scientific publishing, preprints, open access, and much more. Emma has been long involved in efforts to ensure the highest level of scientific integrity via data presentation and making data available alongside publications. In 2021, Emma was elected to the board of directors for Force 11. Emma is a director of strategic initiatives at Protocolsio, the platform she'll be talking about with us today. A bit of housekeeping before I pass it on to you, Emma. Everyone, please add questions you have during the presentation to the question and answer tool at the bottom of your Zoom screen. Emma might answer them during the presentation or during the question and answer session at the end. This webinar will be recorded and it'll be on our website next week. And with that, I'll pass the mic over to you, Emma, and I'll stop sharing. Oh.
That is fantastic. Thank you so much. I'm gonna pull up some slides. So for today, I've got some slides and then I will attempt a little bit of live demo, which I've preloaded to try and avoid internet issues, but we'll see how it goes. Thank you, Kristen, for the kind introduction, but also for the invitation to be a part of this webinar series. I mean, I just have to start by saying I'm thrilled to see funders putting on open science focused webinar series like this. It's really wonderful thing to know that researchers are being kind of better informed about all of the different options and ways there are to make sure that the science they're doing is as available as possible for everybody. So yes, I will talk today about reproducible methods with Protocolsio. So methods do matter for reproducible research. So, I mean, we're all in this virtual world, so I apologize for showing cookies when, if we were together, we'd hopefully be eating the cookies. But in this instance, the cookies here are a representation of data. So this is a screenshot from a magazine where somebody decided to tweak the recipe and they've taken photographs of all of the resulting cookies that they made. So if cookies are data, the analysis of size, thickness, texture, hardness, flavor, all of the different things that you might judge them on, you can actually only interpret those elements, those physiological outcomes, in the context of the tweaks that were made to the recipe. So it's a really important thing in the lab or in whatever research process you're working on. You're producing data. In order to always be able to interpret the data, it's absolutely critical that we understand how you generated those data. But methods are really frequently lost. So these are two tweets from different researchers. So the one on the left is a biologist who was looking for protocol in 1997 paper, where they saw as described in 96 paper, as described in a paper from 87, and eventually hits a paywall and can't get to the information in that paper. And then the researcher on the right is a physicist and had the exact same problem trying to find out how devices were fabricated in a publication. So as previous reference, 2015, back to 2013, back to 2009, only to have the original statement be that devices were fabricated with conventional methods. So the follow-on GIF with the tweet on the left illustrates the frustration of the researchers when they hit a brick wall like this, essentially, to be unable to determine exactly how the methods were performed. And it's not just the papers that lack information. So a few years back, there was a very large reproducibility project, cancer biology reproducibility project, undertaken by the Center for Open Science. And they wanted to replicate 50 high impact cancer papers that had been published in various different journals. So they started looking at the papers themselves to see if they could find the information about the experiments to be able to repeat them. That was not very fruitful. So they also went to the authors, the researchers themselves, to see if they could extract the information, have them go back to lab notebooks or other records, hard drives, etc., to find out how the experiments were performed. Ultimately, it just was not possible to get to that information. So there's a fantastic write-up. There are lots of write-ups about this project. There's a fantastic one in The Atlantic by Ed Yong, recent Pulitzer Prize winner Ed Yong, about this. And in that, he states, the hardest part by far was figuring out exactly what the original labs actually did. Papers come with method sections that theoretically ought to provide recipes for doing the same experiments, but often those recipes are incomplete, missing out important steps, details, or ingredients. And in some cases, the recipes aren't described at all. Researchers simply cite an earlier study. And so it actually was halted after they attempted 18 of the studies. They were not able to repeat. I think they successfully managed to only repeat partial experiments from about 5 papers. And so they stopped because it was too expensive, both time and financially, to try and not actually get very far. So this is a big problem for reproducibility. The science, we may have the data, but we don't know how it was generated. And I think in a way, this is a result of, focusing on research outputs, but in a very single-minded way. So the traditional recognized output has been the final published paper. Now we've shifted slightly, and we're more accepting of preprints, and funders acknowledge preprints and encourage sharing that way too. And we've started to see a lot more sharing of data and code. And there are initiatives around citations as well. So even now, some paywall journals do share the citations of the papers that they have. But methods have been lacking behind a little bit, I think. We're seeing movement and people going in the right direction, but I think there hasn't been perhaps sufficient focus given to why we need to make sure we actually do obtain and share the methods details, the full methods details, alongside all of the other elements that are being generated and produced by researchers. We do really well with data. The last decade has seen huge changes in researcher approach and uptake of data sharing and making sure data are available alongside research papers. Kristen mentioned I was at PLOS previously, and I was there and was involved in updating the data sharing policy that they had on those journals back in 2014. So we introduced there the data availability statement, and actually now that's been widely adopted by a lot of other publishers too. PLOS has a requirement that the data definitively be shared alongside the publication, but other journals are minimally at least trying to get the authors to fill in a data availability statement, regardless of whether they're mandating sharing or not. So we're getting a lot of data, huge oceans of research data. What are we going to be able to do with it? So there's a brilliant quote from evolutionary biologist Dobzhansky from 1973, that nothing in biology makes sense except in the light of evolution. So I've got my own slight twist on this quote, and I would say that nothing in research data makes sense except in the light of how it was generated. So if we are sharing the data, it's really critical that we also ensure that comprehensive methods details are also available, because otherwise we just have all of these cookies with no actual insight into what happened during the method that resulted in, the brittle, hard, lacking in flavor, strange textured cookie that we produced at the end of the day. And this is where Protocols.io comes in. There are other ways, obviously, of sharing protocols too, but I bring my biased viewpoint here as representative of the tool and platform Protocols.io. Our mission is really simple. We want to make it easy to share method details before, during, and after publication. Perhaps best known as an open access repository. anyone can come along and use Protocols.io, can put their methods details onto the platform and publish them, obtain a DOI, make them publicly available. Anyone in the world can then come along, search our repository, find protocols that may help them perform whatever methods they're looking to perform. Originally, it was focused on wet lab researchers. Founder and CEO Lenny Tappelman was a geneticist, and he really built this after struggling for 3 years as a postdoc trying to get a protocol to work. That needed actually a tweak to the protocol, factor of 10 on one reagent, I think, during that protocol. But it took him 3 years to get that. And after immense frustration, I think he and computer science colleagues realized that this would be a really valuable tool for method sharing, to track tweaks and changes to protocols and allow people to share that information really widely with the world. These days, it's used by researchers across all different disciplines. So we span from social scientists all the way through all of the wet lab research to onto kind of psychology, more cognitive things, or humanities, etc. It really can be used as a sort of blank template that you can adapt to your needs for whatever step-by-step process you might be following. It also functions really well as a collaborative tool, so you can share and collaboratively edit things in the same way you would a Google document. All the content that's published is very carefully archived and mirrored, and these days we have a lot of users, just over 100,000, and over 11,000 publicly shared protocols. But this collaborative side, the behind the scenes private, there's a lot more private content, and that's users working on their own space with their colleagues to develop, tweak, optimize the protocols they have. Really good place to start is this welcome screen if you haven't had a look before at the platform. So I'll talk a little bit about FAIR and how Protocols.io allows you to achieve FAIR as the acronym for findable, accessible, interoperable, and reusable. So I mentioned it's free for anyone to come. You can sign up, make an account really easily, and free to publish as well. Everything that's published is fully open access with a CC BY license, and all of the published content is searchable very easily, either at publication level. People can have workspaces. I'll show a little bit more how that looks on the system in a minute. And interoperable, when you sign up, you can sign up with your ORCID ID. If you do publish protocols, they will automatically be pulled in. If you want them to, you can take them off if you don't want them to appear. They'll appear as works under your works on your ORCID profile. So they're recognized as a research output this way. Perhaps less relevant to researchers on the fly, but people who develop equivalent tool or other tools or at institutional level, we have an open API, so people can very easily integrate with the tool if they want to. And many journals and publishers recommend using Protocols.io during manuscript submission. I'll go into that a little bit more in a minute to show some examples. And then funders as well, more and more are recommending Protocols.io in grant guidelines and policies. And some funders are quite strictly requiring method sharing. Whoops, I think I skipped one then. Yeah, so reusable as the next part of FAIR. So the protocols are published with a DOI, so they're very, very easy to cite alongside manuscripts. I'm just showing some examples here. So you can make them available through the citations for anyone. And the nice thing too is if they appear in the reference list for your paper, because you've written your methods up in a protocol, but you still are publishing for some reason in a journal that's paywalled, so people can't access the content of the paper, they will still be able to get to the protocol through the citations. The protocols are runnable, so you can dynamically run a protocol on the platform. So you can, if you're allowed to take your devices into the lab with you, you can run through the protocol on the fly, and I can show that a little bit. But essentially, there's a screenshot here at the bottom. You step through every step of the process. You can skip, you can edit and add notes. So if something strange happens on that day, you can record the run and have notes about what happened at every single step of the process. You can also track reuse a different way. So if people are familiar with GitHub, where you can fork your own version of content, that's exactly the same way that things work at Protocols.io. So once you've published a protocol, well, first and foremost, you can make new versions of your own protocols and make them public. So you can update them. You'll get a new DOI, but they'll all be linked together. I'll show you that in a second too. But you and or others can fork new copies of the protocol. So if you want to make essentially the same protocol but applied in a slightly different context available, you won't have to put it all in from scratch. You can make a fork and then make the changes and adjustments that you need to. So in this instance, these authors have made quite a few different forks, and there are multiple versions of each one. So this is one of our kind of poster child protocols. People can add comments too, so other users can come along and put their comments. It's kind of like a live FAQ onto the protocol. So this actual example from Stephen Henikoff, he had previously already published the paper in Nature Communications, but he was receiving so many email queries about the protocol and the methods that he decided to put the content onto protocols.io so that he could answer the questions in one place. And then people wouldn't need to email and query because the answers would all be tracked alongside the protocol here. So that it can be a real kind of time saver for all researchers involved in that context. Being able to separate out the method from the paper also just increases discoverability and reuse of the method itself. So this is a wonderful example. On the top left is a tweet from a researcher in Chile who was looking for a protocol to do with RNA extraction from primary cortical neuron cultures. Someone answered this tweet on the bottom left. This was a postdoc from UCSF, and they recommended a protocol that's up on protocols.io. And when we looked at that protocol, it turned out it was a method that had been published in a paper as a part of a paper that's published in Gigascience, but the paper was on 3-spine stickleback parasites, so a fish parasite. So the chance of the researchers working on primary cortical neuron cultures finding the paper on the fish parasite as a means to finding a method that would work for them seems incredibly slim, but the fact that the protocol had been separated out for the approach made it just much more discoverable and enhances the chances of people reusing it essentially as the approach needed for RNA extraction, regardless of sample that you're working on. Popping back to Findable, just for Practicality's perspective for information, I mentioned that we get DOIs, we can give DOIs for the protocol, but in the protocol itself under metadata, we will always include the manuscript citation as well, because we're very conscious that researchers want to have the citation to the paper as well, perhaps as the protocol, these two slightly different things. Content is all archived in lots of places. So clocks is commonly used by publishers, but I think researchers are often unaware, but it's called controlled lots of copies keep stuff safe. So it's a kind of dark archive really to make sure that content that's published is safe somewhere should anything actually happen to the companies that put them out. And then we have backups and are working to improve our indexing. So Europe PMC is going to potentially start indexing our content, starting with coronavirus relevant things. But also, if you do put content on protocols.io, it's incredibly easy to export it back out again in a variety of different ways, and also tie into multiple different external drives. So for you to put protocols alongside data, for example, is very, very easy to control. I mentioned that over 500 journals and publishers recommend protocols.io. There are lots of funders as well, and now more and more institutions are signing up for site licenses. So it is free to use and publish. The private side is a bit more limited. So that's why we have some people who sign up for a license with us. It just allows for more access to the private workspace features and functionality. But in the context of integrating protocols into research articles, these are a few quite recent tweets from the last few months. There's another nice example of a Gigabyte paper with an embedded Protocolsio protocol collection in the methods. So Gigabyte and GigaScience were one of the first journals to encourage authors to use Protocolsio. In the middle here, there is someone who's published the paper in Current Biology and have popped the method onto Protocolsio. And then on the right is we've had a small partnership with Springer Nature. They had previously published open access book chapters, which were protocols, and we've now put the content of those protocols onto Protocolsio to make them more dynamic and interactive for researchers to actually use. And how does this look actually in a paper? So this is a PLOS Biology example. They are really neatly interlinked. So the paper is published on PLOS Bio, and if you scroll down to the materials and methods, there is a link out to the DOI for, in this instance, a collection of protocols on Protocolsio for the various different methods that are available through that paper. And if you click the link of the DOI, it brings you to Protocolsio. And I mentioned earlier that you can make new versions. So the really brilliant thing about using Protocolsio for the methods of your research articles is that you can update them. And so in this instance, the authors have, since publication, updated the collection, one or more of the protocols in this collection, to a newer version. And if you follow the link, you'll always be told if there is a newer version. So I call this dynamic permanence. But what's really handy about this is that if you realize there's a mistake or you want to offer additional clarifications because someone's tried to repeat the experiment, you can do that and you can make the new version available, and you don't have to issue a correction with the journal at all. So that would result in, a flag of correction available in all of the various different places like PubMed, et cetera, et cetera. You can completely bypass that by putting the new versions up on Protocolsio of the methods themselves. Another recent partnership is a new article type that we have in PLOS One called Lab Protocols. So they've launched this very specific article type in which the authors can publish just the method itself. So the paper has a kind of wrapper of abstract and context and a bit of background information about why the method is perhaps an improvement on things that existed before, or just more information about it as a new method. But the method itself is fully available on Protocolsio. So you can see at the top here, that at the top of the article, there's a link to the protocol. And if you jump to the protocol, it will tell you that it's a peer-reviewed method available in PLOS One as well. So they're really nicely interlinked. The paper also has a static copy of the PDF in the Figshare viewer that they have there, so that you can see it on the fly in the paper itself too when you look at the HTML. And so by being able to put methods on Protocolsio alongside various repositories that you have for data, we start to see researchers now really managing to practice open science with all of these interoperable modules. So these are a few more tweets that I've pulled from pretty recently, actually. So the first one on the left, Esther there, has got paper on bioRxiv, protocol on Protocolsio, and package of presumably code on GitHub. Person in the middle, Conrad, code, protocols, and paper are fully open. So this lovely way of putting all of the separate pieces together and making them available. Allen Institute as well, they are freely sharing. Reproducible methods is an essential component of open science and open access. So they did a push around Protocolsio during Open Access Week and hosted a webinar for that then too. And then on the right, my first serious attempt at open science, and also finally the first paper of my PhD, and way to make a good start. So the preprint, and then data and code on OSF framework, and protocols on protocols.io. And so it seems like a lot of effort to do this, but actually I think if you start to undertake your research this way, putting those various pieces into the separate places, you actually make life a lot easier for yourself when it comes time to publish. And if you're looking back at the things you've done in the future, it's often noted that your most likely future collaborator is yourself. So if you've done this and kept all of your information really nicely in different places, you will make your life a lot easier down the line as well. And I think we're all probably a bit fed up of hearing about the pandemic at this point in time, but it did this, the situation, the global situation that we're obviously all still in now, has shone a light on the need for open science, and it shone a light on the need to share methods too. So very early in 2020, we noticed that we were getting a lot of coronavirus relevant protocols being published on the platform. So we set up a coronavirus method development community. This is probably one of the fastest organically growing communities that we've had on the platform, and a lot of researchers joined, shared methods very early on, and I'll show you a few of these. The numbers are much higher than this now. I think I'll show you, just highlight that in a moment. So this is a short movie, it might run, but I'll do a bit of a demo anyway, but I'll let this run because it reminds me to show the different things. So we have different versions, we have different components, and it's a step-by-step protocol. So you follow all of the steps. This is how you can add a comment on the fly and post it. You can either do that privately or publicly. There are places to add all of the variety of other information that you would need, including materials, reagents. You can put catalog numbers. Under the metadata, there's the protocol citation, and if there was one, the manuscript citation would be there too. That's a very brief view. I will go on. I'm going to jump out of that actually, and do a little bit of jumping through some of the other things on here. So this was just the landing page. This is the protocols.io/welcome. And if you get to here, although I'm signed in, you can see my face in the top right corner, you would have the option to sign up on that page. It's very, very simple. And if you just want to have a look around here, there's a few places where you can just explore, see some quotes, but also see some examples of nice protocols and featured workspaces, including that coronavirus method one I just talked about. And I will jump to that one now. So this is it presently. If you find it, you'll land on this page, which is the timeline. You see people have been commenting in the last week, and there are 262 publications and lots of members. You can have discussions and seed discussions here too. So very early on, we saw discussions around, good approaches to sequencing, I think, in countries that weren't as well developed as other countries. And so there was some really great advice offered there for that. If we look at publications, we can sort these things. So if we sort on views, we can see this example from Josh Quick, which I will go into in a little bit more information in a minute. This was one of the first ones shared at the start of the pandemic, January 2020, I think, although this is a subsequent version. But you can see there's just lots in here. You can poke around, you can search on what's in here if you want to, and see what's there. So this is a public workspace where if you join, it's open for anyone to join the workspace. You can have full access to all of the information in there. This is like a profile view, but you can jump also to a folder view, which has all of the files in it. And you can actually access the protocols this way. And this is why I preload pages, because my internet's not great when I'm also Zooming. So you can see all of these files are in here, who owns them, and a bit more information, so on. For a more basic workspace, so as not to kind of blow your mind, if you set up your own workspace, you can just generate a little bit of order too, if you're thinking about how to share your protocols or how you might be able to implement something like this in the lab. we know people are short on time. So if you did nothing else at the moment, if you knew you had Word docs or PDFs of your protocols, you can make your own workspace, put a folder in there for PDFs of protocols that I intend to import in the future. And you can literally just drag files into this folder if you want to put them on here. So you can save them all in one space at least. You could also share them that way with colleagues, or even publish just the file as an uploaded attachment to a protocol. But you can also create these other subfolders, protocols that are in development right now. So you might have just a couple of protocols in here. And if you store runs, it might be that you're working to optimize a protocol. You can run it and store the individual runs, which you can correlate back against data that you generate each time. So you know what happened when you took that run of microscopy images, you know exactly what you did in the sample preparation that day to generate those images, for example. And then you can publish, you've got your working protocols, maybe you've published some, or you've got them unpublished and you're sharing them with colleagues. It's all very, very simple to do. And so that's the file manager view. If you click on one of these, you can edit them, view them, you have all the options to publish, share, etc., etc. So I've got one here. This is just a brand new protocol. I haven't done anything yet, but you can very easily add sections. And step one, just to show how simple it is, I can add new steps, and then I can add a new section, and they get color coded. So you can divide up into sub experiments during this. You can include, if you include kind of components, they show up a little bit more obviously. And if you're making a master mix for something, when you run it, you could actually scale it so that the volume would be scaled for each of the amounts that you've put in that location. You can add kind of critical steps on the left, which just flag up at a high level what it is you might be doing at this step. So there are various different ones. And so this is the edit mode. You can toggle very easily between edit and view. We won't fill in the rating right now, but if you're using it, you should feel free to fill that in. And so from here, this is the view if you're kind of coming in and actually viewing someone else's. And from here, you can perform a run, and you can record the run and store it in the folder where you're optimizing your runs if you want to, or wherever you choose to do that, and so on. But you also have all of these options to share. So this, if you're collaboratively editing, you can just get a link like you would a Google Doc to share with other people. You can specify by email. You can, if you know your lab has its own workspace, you can share it with that whole workspace if you want to. And when you share with people, you can control the amount of privileges that they have. So it's very much like Google Docs. You can allow people as much or as little access as you want to the content that you're creating. But you can also publish, and the publishing flow is pretty much just a few steps of it. Literally, it's not even 5 minutes to run through the 7 steps here. I won't do it now, but it's incredibly simple to get a DOI. When you've got a DOI, that version is fixed and you won't be able to edit it. So just be mindful of that. You can make new versions, obviously, but it's almost too easy. Sometimes people, I think, make them and then realize that they did it and they've still had tweaks and things to make. I mentioned the Josh Quick. This was probably one of the first protocols shared related to coronavirus. And you can see here, the first one was published in January 22nd, 2020, and there have been 2 subsequent versions. So this is a really long and complicated protocol. And the reason they were able to get it up so quickly at the start of the pandemic is because Josh Quick had previously input the Ebola virus sequencing protocol. So prior to coronavirus being an issue, there were obviously large Ebola outbreaks, and this was something that they'd been working on at that time. He's funded by the Wellcome Trust. There's an Arctic preparation or epidemic kind of disaster preparedness funding that he's funded by. And this was put up as a result of that, this Arctic group. So they had published the Ebola virus sequencing protocol near the end of 2019, and had been able to very quickly make a new fork for the coronavirus sequencing protocol. So having that available and published meant that they could just generate this content so much more quickly and share it with the world. So we have, sorry, I'm jumping around a bit. We have the functionality to compare. So I won't click that now because it will take a long time to load on my laptop while I'm on Zoom as well. But you can pick which version you want to compare. And this is, I preloaded it earlier. So we've got the first coronavirus sequencing protocol on the left and the Ebola sequencing protocol on the right. And you can see the highlighted sections, the places where they changed things during that protocol. So it was a, different template RNA quantities and total amounts, and just different, slightly different notes added into the protocol relevant to Ebola, relevant to coronavirus. So sharing the methods this way can actually really, really accelerate the science and the discovery and the ability to share absolutely critical methods with the rest of the world, essentially, actually, in a context like this. And so in terms of tracking reuse, what I love to show on the Ebola virus sequencing protocol is, so you have the steps, you have these various tabs. The forks tab allows you to see different forks that have been made of a protocol. So this one we can see had its fork to the coronavirus sequencing protocol. And if I actually click to open all and expand it right out, you can see that it's just gone on to be forked and versioned multiple times by many different people, actually, as they've adapted using different tools, equipment, whatever they have available. And so I think this really highlights the power of sharing your science, your methods, in terms of the reach that can subsequently have, and how people can use it and go on, adapt it for their own purposes. Most protocols won't have that quantity of reuse, but I think that's a really nice example in the context of the need for open science. I'm trying to think what other things I didn't show you yet. One of the best indicators of reproducibility that we have on a protocol is this button here, which is the Works for Me button. So this one has been clicked by 40 different people. So if you are using protocols on protocols.io, please do log in and click that button if you do get things to work, because it really is perhaps one of the best indicators, I think, of reuse and reproducibility that we could possibly get. We can track metrics if people want to have a look at how it's being used and how often it's being accessed by people, but also bookmarks, the number of times it's been exported. We know a lot of people still are probably printing off PDF to use for themselves. There have been a lot of exports for this protocol, the forks, the comments, the run records, all of this is tracked. And I'd mentioned the comments. So this one's got just over 100. And just to show kind of how that looks, people will come along and they can add a comment on an individual step, or they can add a comment on the protocol itself at the very top, a high level comment. But they will pop in a question, and hopefully the authors will answer queries and questions that they input here. And in this instance, we know there's been a lot of back and forth with the authors and so on. And if I wanted to write one, you can just add your comment here. If you're feeling shy, you can make it privately, and just the authors will be alerted, but no one else will see it. Obviously, we encourage that public sharing, because if you ask it, chances are someone else might also be thinking the same thing, and you can post and then the authors will be alerted. So it's incredibly simple to use, really. I feel like I've covered most things. I'm just checking my list for the parts I was going to demo. So I'm happy to answer questions. I'm happy to show other things if people have kind of things they're curious about, how they work, but I've probably overwhelmed with tons of information at this point in time.
Great, that was fantastic, Emma. It's really amazing to see the how it works inside the system. The comparison tool, I think, is just really cool, and I can imagine how helpful it'd be for researchers to kind of walk through and explore and to kind of really dig deep in there. We do have a question about. So Dawid says, "This is a really cool setup. Do you have any example of what a protocol would look like in social sciences? For example, how does it show information about Qualtrics survey or MTurk task? Do you have an example of that, maybe?"
I should have come better prepared. Let me just talk and poke around while I'm talking and see if I can find. We have a bunch of different discipline protocols that I've got bookmarked, but I'll just have to look them up while I'm talking to you. One thing I didn't show you is the smart component. So if you're kind of doing survey style, we've added fairly recently this smart component where you can have key pair values. So you in the protocol will input the input things that you want someone to be looking at, and when they run, you can require an answer. So when they run through the protocol, they have to answer the question, if that makes sense. They can't run and proceed until they've got there. I'm trying to see if I've got any good examples. I don't want to bring one up if it's not going to be useful. I should have looked better, come better prepared.
No, that's okay. It's great. Thank you. I have a question. What do you think would be the sort of the most important factor to get more researchers to share their methods? What is like one thing that, like, what do you wish that is happening? Have more?
Honestly, I just wish that there was greater awareness of how important it is to track this. Even when I bake sites, a long time since I've done anything experimental or research-based, but when I bake something in the kitchen and I do something different on a given day, and then for the life of me, I can't remember what it is that I did differently, but man, it tasted better when I did whatever it is I did. That practice of better recording what you do when you do it, so that you have got the correlation between what you've done and how it worked out, just needs to become standard lab practice. It needs to be the thing that researchers are doing all the time, and if it is more of a kind of survey style, what was the process and procedures, what things happened differently on that day. If you're bringing participants in, was it raining? Is that a factor that, they all came in and they're all kind of upset because they've had a crappy journey to get to wherever they're going to on that day. You can really track all of those factors and things, but it has to be understood that that's important to do, I think. And I'm not sure we're training people to do that right now. So I think there's just an education piece about, if you do some stuff now, you're going to save yourself a lot of time down the line.
Great, thank you. We don't have any open questions. Any other open questions right now? I had a few, but you've answered them, all of mine, very thoroughly as you went through the presentation. So I think that has kind of a byproduct of being very thorough in your
that's good.
It's great.
Good. I'm failing to find an example for you now, but I can try and send some later. I should have thought.
No. I can if you share some with me, I can also put it in the email that goes to registrants. So
perfect. Yeah, I can do that.
Okay. Well, I think we'll close a little bit early. Thank you so much, Emma. It really was a pleasure to have you here with us today. And yeah, and thank you all to those who attended. If you have any feedback or have any questions, you can send it to open@templetonworldcharity.org, or you can also, Emma, can I share your email as well, maybe, or?
Oh yeah, sure.
Um,
I'll share the slides so you can share those, and it's in there, but it's just Emma@protocols.io too. So it's very perfect.
Okay, and the webinar will be up on our website next week. Thank you. Thank you, everybody.
Thank you so much. Stay safe, everyone.
Thanks, Emma. Bye.
Bye.